Good morning. Okay, so this is the first lesson on properties of functions, or functions and relations, Chapter 5. Alright, so the main thing that this is to do with, we're also going to cover coordinates, or review coordinates, because I think we've seen this from grade 9. But overall, this whole unit that we're going to go over has to do with kind of the, there's the y-axis, there's the x-axis, different lines on this kind of coordinate grid. Okay, so you can have something like this, or that's a graph right there. Or if I wanted to draw another one, again, you have the x and the y. You can draw another line, maybe like this. So there's kind of infinite number of lines that you can draw on this coordinate system, and that's what we're talking about. We're talking about the properties of lines on these graphs. It's essentially what this whole chapter is about. Next chapter, we're going to be going on to only straight lines, which are called linear. So if you have another one, an x, y graph, that's an example of a linear, completely straight. Alright, so now to go into it, we have some very important concepts called domain and range. So let's define what those are. Alright, so domain is the set of first elements of a relation. So generally all these lines that I drew are called relations. Okay, so a relationship between the x unit and the y unit. So if you have an x unit here, it corresponds with the y unit there. So that's what a relation is. It's just a relation is just some sort of line on this graph. All right, the first elements of a relation. That usually always means the x unit. Okay, so usually x values. All right, so now let's go into range, the second piece. You can guess it's going to be the y value that corresponds after that. So this is all the x values of the graph. You can see that they use up all the x values that you can see. The range is the set of second elements. Elements just means things, kind of. The set of second things, or the set of corresponding things. It really just means the y unit, whatever that is going to be, of a relation. Usually y values. Alright, so now we're going on to the definition of a function. It's the third definition that we need to know. Is a function is certain lines here. Okay, so I know that these two are functions and this one's not. So we need to know what a function is. The reason why we need to know what a function is because it only has certain properties that you can use in math. And if you don't have a function, then you can't assume those properties. So the two things that you need to know is when every x value has a y value. So if every x value you have has to have a y value, it can't have no y value. Okay? An example of one that would not is maybe a line that goes, has nothing, and then continues like that, like a gap in there. Okay, so that's one thing that functions have to have, and you also have to have only one y value per x value. So an example here is if you look at this graph, this x value here has only one y value. This x value only has one y value. This x value only has one y value. If we look over here, this x value only has one y value. This x value only has one y value. You have to go completely vertical from the x to see kind of this. But if we look at this one, if we look at this x value, then we go down and up. 1, 2, 3. This x value has 1, 2, 3 y values. That's why this is not a function. Okay? So those are the two things you need for it to be a function. I'm going to add one more relation. So what we saw up here, relation just means a line on a graph, does not have to be a function. That's pretty much what it means. Or a list of items linked to one another in a certain way. There we go. Alright, so let's identify some functions. Here I'm going to put, this is one way of representing functions. We'll see that there's 4 different ways of representing functions. Just one way of representing. And this one's a bit strange to see at first. A relation that associates given shapes with the number of right angles in the shape. Okay, so you know a right triangle only has one right angle. Okay, so that's what all this number is saying. It's saying when you have this object, that's the answer. The answer for acute triangle is 0. The answer for square is there's 4 right triangles. The answer for rectangle, 4. Regular hexagon, there's 0. Okay, so what this is saying is these are points on kind of a graph if you want to represent it that way. But you don't have to represent it that way. You can just write it out. Each one that you have. So this is 1. This is an x value, the first one. And then it goes comma, and the 1 is a y value. The acute triangle is an x value, and then it goes comma, and that's a y value. The square is an x value, and the 4 is the y value, and so on. They're just, and they're in brackets. So that's kind of how it's representing right now. That's kind of what it's doing. The x values are the shapes, the y values are the answer of the number of right angles for this one. And the one thing when you're representing it, a list like this, they're called coordinate points. We have 5 coordinate points. You have to put curly brackets, these funky curly brackets, to close it off, saying the whole, the curly brackets means the set. The whole set is containing 1, 2, 3, 4, 5 coordinate points. Okay? And it's a relation with x and y. X is related to y, x is related to y, this x is related to that y, and so on. So is this relation a function, it's saying? Well, we have to look at our definition. When every x value has a y value. Yeah, we have all the x values having a y value. So that's good. The other one is only one y value per x value. Okay, so we have to actually look at the numbers here. So we have right triangle, acute triangle, square, rectangle, and regular hexagon. So it only shows all these x values are different x values, and they all have a y value, so that means there is only one y value per x value. So that one is a function. Alright. If it was not a function, an example of that would be if right triangle was there and it also said right triangle here, and then it would say right triangle has 1, and then it also say right triangle has 0, which doesn't make sense, which makes it not a function if that was the case. Okay, so let's go to domain. This is important. You're going to be going through this a lot. Domain, this is the set of first elements of a relation, usually x values. So what's our x values here? Well, we have right triangle, acute triangle, square, rectangle, and regular hexagon. So we do this curly bracket because the domain is the set of x values. So our x value is right triangle, acute triangle, square, rectangle, and regular hexagon. And then closed off with curly brackets. You can see we have 1, 2, 3, 4, 5 x elements of the domain. 1, 2, 3, 4, 5. Now the range, you just mention the y values. If you have ones that are repeating, like a 4 and a 4, you just write it once. Okay, so what are the y values that we used? Usually you go from lowest to highest. We have 2 zeros, and that seems to be the lowest, so I'll write 0, comma, what else do we have? We have a 1, comma, and we have a 4. We have 2 4s, but I'm only going to write it once. Just saying that we use up the 4 in our process. Okay, so that's our range. Alright, now let's go on to B. This is 2. It's the second way of representing relations or functions. And what it is saying is this side here is your x values, this side is your y values. And the arrow represents kind of the comma. Okay, x arrow to this y. So an example here is saying 1 goes to -1, 1 goes to 1 as well. 4 goes to -2, 4 goes to 2 as well. 9 goes to -3. Okay? And kind of the relation they're using is these set of words. Is the square of. So 1 is the square of -1. -1 squared is 1. 1 squared is 1. So that's just the relation. But really the numbers is the important part. So is this relation a function? We'll look at the definition again. When every x value has a y value. Let's see. There are arrows coming from every number, so therefore they all have y values. Now let's look at 2. Only one y value per x value. So if you look at this x value, it has 2 y values. So that means no, it wasn't right for number 2. So that means it's not right at all. So if you find one spot where it doesn't work, the whole thing is not a function. So that is not, because 1 has 2 y values. And it can only have one. Domain. What's our set of domain? It can still have a domain if it's not a function. It's just called a relation. So our domain is our set of x values, 1, 4, and 9. Our range in these curly brackets is -3, -2, -1, 1, and 2. There we go. So that one is a pretty good way of representing it, I would say. So now here's 3 way of representing. So we have number of marbles, it says, is the variable n. Mass of marbles for mass of marbles is the variable m in grams. All right. So they're saying if there's 1 marble, it's going to be a mass of 1.27 grams. If you have 2 marbles, 2.54, 3 marbles, 3.81, 4 marbles, 5.08, 5 more marbles, 6.35, 6 marbles, 7.62 grams. Okay, so you can see it goes up as you get more marbles, which makes sense. Okay, it's going to weigh more when you have more things. So the first question, is this relation a function? Well, first of all, does every x value you see have a y value? Yeah. So this is kind of the x value. This is a y value. This is called a t-chart or a t-table or that sort of thing. Is this relation a function? So we got that first one. The second one was, does any x value have more than one y value? And let's see. 1 only has 1, 2 only has 1, 3 only has 1, 4 only has 1, 5 only has 1, 6 only has 1. So that works. Yes, the relation's a function. Okay. Identify the independent variable and the dependent variable. Okay. So dependent variable is always the y-axis, and it means depends on the other. Okay, so it means it depends on the other. So if we look here, number of marbles, n, or mass of marbles. So what you ask yourself is, which one depends on the other? Option A is, I'm going to just write it out. You don't have to do this every time. Number of marbles depend on the mass of marbles. Does that sentence make sense? Or does B make sense, where I flip the other way? Does the mass depend on number of marbles? So I always ask myself these two sentences when I come to the two variables. I just switch them both and try each way to see which one depends on the other. Does the number of marbles depend on the mass of marbles? Not quite, because you could just have a really heavy marble. So if they could say 5 grams, it could just mean one heavy marble. So you don't know the number of marbles based off the mass. So it doesn't really depend. The number of marbles doesn't really depend on the mass. So it's not really that. If you read this one, it makes more intuitive sense. The mass depends on the number of marbles you have. Okay? So the mass depends on how many marbles you have. It goes up as you go more marbles. So this one is the y, mass is the one that depends on. Okay, mass depends on. So mass is going to be our y-axis, the dependent one. Okay, so that makes sense here. Y is this one, x is this one. Generally in T-charts, they'll put the x one as the first column and the y as the second column, but not always. Alright, so mass is dependent. That means the number of marbles is independent. You don't need a mass value to have a number of marbles, but you need a number of marbles to have a mass value. Okay, write the domain and range. So let's start with the domain. So you just write domain ... and then you start with the set. Our x values, 1 to 6. So our domain here is 1, 2, 3, 4, 5, 6. If it keeps repeating like 7, 8, 9, 10, you just usually go ... and that means it repeats the pattern that it's going. So it's going up by 1 every time, so that means it's going to keep going up by 1. And one thing to note is there's no part marbles. So it's the natural numbers we have here. It's not 1.1, there's not 2.5, there's only 1, 2, 3, and all that. Now let's talk about the range. And we can see just these other values that we have. Okay, so 1.27, 2.54, 3.81, 5.08. I'm not even going to finish writing it, because if you look, there's a pattern. It goes up by 1.27 every time, which makes sense because you're adding maybe similar marbles every time. So I'm going to go ... it continues. And that's our range. So it goes up by 1.27 every time, 1.27 grams. Alright, so now we've seen 3 ways of representing functions or relations. So this one's really another way of representing it, or this goes into something called function notation. Is what we're going to be trying to do. So it says the equation V equals negative 0.08D plus 50 represents the volume in V liters of gas remaining in a vehicle's tank after driving D kilometers. The gas tank is not refilled until empty. Okay, so describe the function. Write the equation in function notation. Okay, so we need to know how to do function notation. It's not too complicated, but it's hard to understand. So starts with, so here if I read this equation, you kind of start with 50, and for every kilometer you're going to minus off 0.08. So it starts with 50 liters in your tank, and each kilometer takes off 0.08 liters of volume. Okay, so if you went 1 kilometer, you would then have 49.92 liters of volume left. Alright, so how would you write it in function notation? You just write the same thing they have up there, but your main variable, this is the v, in this example, the v is kind of like the y, and the d is kind of like the x. Generally they show it where the y variable is kind of on its own, and the x variable is on the right side. This is to start off with. As you go further in math, that's not really the case. But we are going to write the same thing. The volume depends on the distance you go, is kind of what it means. And then we just copy down the same exact thing. Alright. What this means is volume is a function of distance. This is very confusing because it looks like v times d, but it's not. This is kind of its own variable. This is just the one variable. So this is synonymous with kind of just y. Okay, this whole thing, v with the d in brackets. Okay, so it doesn't mean multiply at all, which is very confusing. Okay, so you have to remember this v kind of bracket d bracket is just one variable. It's just a y. Y equals this. They just have that d there in brackets to show you that this volume depends on your x unit, which is distance. So here, determine the value of v of 600. Okay, so let's just write down our formula again, just the way it is. V of d is negative 0.08d plus 50. So what you do is when you see this v of 600, it's meaning the x unit, or in this case the d unit, has to be 600. So v of 600 is going to be what? And what that means is d is our distance. So that means 600 is our distance. It means our person's going 600 kilometers. So wherever you see a d, you put a 600 is what it means. There we go. Okay, so really it still means just this is the same thing, if you remember, as a y. So y equals negative all this. Okay, so now we can simplify it. V of 600, which is just one variable, is equal to negative 48 if we times those two, plus the 50. Now negative 48 plus 50 is just 2. So what this means is the volume when you've traveled 600 kilometers is just 2 liters left. 2 liters remaining of your car, or of the vehicle. Okay, determine the value of d when the volume with d is 26. What does this number represent? Always in these questions you want to go back to your main equation or your function notation equation. Function notation just means that you have this weird one that looks like two variables, but it's really one. Okay, it's just saying that your x value is the bracketed one. So v of d is equal to negative 0.08d plus 50. So you always start off with that, and it's saying this whole variable, remember this can mean y, is 26. So they're saying just that one variable is 26, or the volume for some distance is 26. They want to know how far you go with that. So instead of v of d, let's just put 26 in brackets, because that's what they're saying it is. And then we write everything else the same. So this case, we don't know what d is, and they want us to solve for it. Okay, so they're saying if your volume is 26 liters of gas remaining in your tank, you started with 50, remember? How far did you go? So now we have to do a bit of algebra. Let's try to solve for d by itself. So we're going to negative the 50 to both sides. So we get 24 is negative 0.08d. And then we've got to get d by itself still, so it's being multiplied by negative 0.08. So let's divide by negative 0.08 to both sides. And therefore d is 24 divided by 0.08, which is 300. 300 kilometers must have been how far the person went to have 26 liters of volume left in their tank. Okay? Those are the two types of function notation questions that you can have. Is what is the y value and what is the x value? They're different variables, but they always can be shown back as the y and the x. All right. Last part of this, coordinate review. If you know this part really well, you can skip over it. Label x and y axis on each graph. So we know y is always the vertical one, the up and down one, and the x is the horizontal one, the sideways one. That's always the case. So here, you know that when you have a coordinate point in brackets with a comma, the first one's your x, the second one's your y. First one's your x, the second one's your y. So if you want to find out where the point A is, it's 1, 2, where you go on the horizontal one first, and then you either go up or down from there. So 1, and then we go positive 2, up 2 from there, right there. So that's our A. B, negative 4, 0, we go negative 4 on the x-axis, and we don't go up or down any. So we put B there. Next one, C, negative 7, 7, we go negative 7 horizontally, and then positive 7 up. And then D, 9, 0. So we go 9 on the x-axis and 0 up or down. So D. E is negative 8, negative 2, negative 8, negative 2. F is 0, 5. And G is negative 1 on the x-axis plus 1, or up on the y-axis. Alright, so that's generally how I always label it, is I always go on the x-axis first, and then I either go up or down depending on what the y number is. So I'm not going to do the rest, but that's how we do coordinate axes. We never went into this kind of quarter, so we would need a positive x number and a negative y number to go in here. So something like k would be down there somewhere. Alright, and then here's some more practice. Give the coordinates for each point on the graph. A is there. So how do we get there? We always go on the x-axis first. You'd have to go negative 6. And then up how many from there? 1, 2, 3, 4, 5. Alright, B. Where's that? Right here. We'll have to go to the 1 spot, and we'll have to go up from there. 1, 2, 3. So 1 on the x-axis, 3 on the y-axis. So you can see if you see 1 and you see 3 there, they kind of link up like so. C, you go 6 and 0. 6 on the x-axis. D is negative 1, negative 5. E is negative 6, negative 5, because I went negative 6 on the x-axis, and then I'd have to go down, which means negative. F is 4, 7. G is 4, negative 2. H is negative 5, 0. I is 0, positive 6, because you don't go anywhere on the x-axis, you just go straight up. J is going to be 0, 0, right in the center, and k is 0, -7. Alright, so these are the practice questions that you need to go through to make sure that you can master these concepts. Thank you.